Welcome back to stoichiometry. So we're going to move into our next type of stoichiometry problem, which is going to involve mass. So we might be going from a mass to moles. We may be going from moles to mass. Maybe we'll be asked to go from mass of one certain substance to mass of another substance. So we're going to look at an example together. Again, these are PowerPoint problems, so these will be listed in our PowerPoint, and then you're going to have a couple of practice problems down below that you can take your time with, try them out on your own, and again, the next time we meet, the answer key will be posted on our classroom so you can check your progress. So back to the first problem, we look at our PowerPoint problem. We have an equation here, so we need to balance the equation first. Remember, with stoichiometry, we always need a balanced equation. If we look at our reactants here, we have a hydrocarbon, we have oxygen, it's producing carbon dioxide and water. You should remember from our reactions chapter, this is a combustion reaction. So when we have a combustion reaction, remember we said we like to balance carbons first, then hydrogen, then save oxygen for last. Okay, so we have 5 carbons on our reactant side, so I'm going to put a 5 in front of CO2. We have 12 hydrogens on our reactant side. I have 2 on my product side, so let's put a 6 here. If we do that, that means we have 10 oxygens from CO2, and then the 6 goes to oxygen, 6 oxygens from H2O. So in order to get the 16 oxygens that we need on our reactant side, we're going to have to put 8 as our coefficient here. All right, so we have a balanced equation. Time to look at our question that we have. So if you have 100 grams of pentane, which is going to be the C5H12, how many moles of oxygen do you need to completely burn it? Just like with our mole-to-mole problems, just like with our Oreo stoichiometry problems, we always want to start with our given. So we're going to go ahead and start with 100 grams of C5H12. Eventually, we want to get to moles of oxygen. Okay, so we're going to have to use our dimensional analysis steps here to cancel out the units we don't want to get to the units that we do want. So I have grams of C5H12, and I want to get to moles of something. In order to get rid of these grams, we're going to need to factor out grams of C5H12. It doesn't tell us anything about a molar mass here of pentane, so we're going to have to figure that out on our own. Remember, 1 mole of any substance is equal to its molar mass. So we know that 1 mole of C5H12 will be equal to its mass on the periodic table. So if I have 5 carbons, each with a mass of 12, and then I have 12 hydrogens, each with a mass of 1. We can add that up. That should be 72 grams. And when I post the answer key, I'm going to be able to show you that calculation if you need some help with determining your molar mass here. So now grams of C5H2 factor out. We're at moles of C5H2. Okay, and we want to figure out how many moles of oxygen we need to completely burn it. This is where our balanced equation comes into play. So we want to get rid of moles of C5H12 and get to moles of O2. So how are these two related? If we come back to our equation, our balanced equation, we know for every 1 mole of C5H12, we need 8 moles of O2. So we can say for every 1 mole of C5H12, we'll need 8 moles of O2. So moles of C5H12 factor out, we're left with moles of oxygen on the top. So it's going to be 100 times 1 times 8, all divided by 72 times 1. That should leave us with 11.1 moles O2. All right, so the next problem, we're going to look at one more together, and it's going to look really similar. I'll point out where the difference is. If you have 100 grams of pentane, same as before, how many grams of oxygen do you need to completely burn it? We're going to just need to add on one extra step here. So we're still going to start with our given, which was this 100 grams of pentane. We want to get rid of grams of pentane, and we'll have the same molar mass that we had up here, 72 grams, C5H12. We know that will be the mass of 1 mole of C5H12. Okay, and we want to know how many grams of oxygen. So the next step we're going to have to do, we're not going to be able to go directly from grams of C5H12 to grams of oxygen. We need to use our mole ratio to know how they're related. So again, we'll use our balanced equation like we did up here. We know that for every 1 mole of C5H12, we're going to have 8 moles of O2. Okay, so we fill that in. And now if we have moles of O2, just like the second step here, if I have a mole of any substance, so if I have a mole of O2, it will be equal to its molar mass. If I have 2 oxygens, each with a mass of 16, that's coming directly from our periodic table, our molar mass will be 32 grams O2. Grams of C5H12 factor out, moles of C5H12 factor out, moles of O2 factor out, and now we multiply the top and divide by everything in the bottom. That'll leave us with 355 grams O2. Okay, hopefully this helps you get started with these practice problems that are listed down below. Again, remember that all of these answers will be posted on Google Classroom for you the next time that we meet. And this does not have to be turned in. Okay, this is for you to practice. Let me know if you have any questions.